How much voltage do you think is needed for a watch to work? For example, this wristwatch I have works with a 1.5 volt battery. So, can a power source that's only a third of that energy overcome gravity? Well, just recently, such a discovery was made. It was discovered that an electrical force of just 0.55 volts in the Earth's upper atmosphere can launch some particles into space. So this force is pushing against gravity. So how is this possible? How can such a massive force like gravity overcome by such a weak energy? Normally, gravity pulls everything close to the Earth downwards. However, a series of different events occur in the Earth's upper atmosphere to the strong radiation coming from the sun. Sunlight hits the atoms in the upper layers of the atmosphere, breaking them apart. As a result of this collision, some parts of the atoms break off, leaving behind small particles. These are called ions. This process is called ionization. Under normal conditions, these particles should be pulled down to Earth by gravity, right? But what has been observed is the exact opposite. Ions are being launched into space, pushing against gravity. Well, scientists thought about 60 years ago that there was a weak electrical field pushing these particles into space. And this field has finally been measured. It's such a small amount of energy that it couldn't even power a wristwatch. Of course, don't be misled by me saying energy. Would be more accurate to call this a potential difference. The potential difference refers to the difference in electrical voltage between 2 points. And this difference applies a force on the particles, causing them to move. The electric field here was measured at 0.55 volts. We learned this thanks to data from NASA's rocket called Endurance. The rocket launched in May 2022 reached an altitude of about 770 kilometers, which is the upper parts of the atmosphere. The rocket, measuring the changes in electric charge here, detected a potential difference of about half a volt. Even this small voltage is enough to push the electrically charged atoms or molecules in the atmosphere upwards against gravity. Researchers call the area where this force exists the ambipolar electric field. Ambipolar? It's bipolar. So this field affects both positively and negatively charged particles, causing them to escape into space. The existence of this field was first determined by observations made in the late 1960s. At that time, spacecraft passing over the poles detected a flow of charged particles. Scientists named this the polar wind. At that time, spacecraft passing over the poles detected a flow of charged particles. Scientists named this polar wind. But there was something strange. Even though these particles move at supersonic speeds within the polar winds, they were cold. Normally, as a particle accelerates, its kinetic energy increases. As this energy increases, it's expected that the heat would also increase. And this is exactly where the strangeness lies. These particles are cold. Researchers suggested that the reason for this is the ambipolar electric field. This field provides the necessary force to accelerate the particles here. But while doing this, it only increases their kinetic energies to a certain extent. So this increase doesn't turn into heat. That's why particles can stay at low temperatures, even while moving very fast. So why did it take 60 years to make such a discovery? There's actually a very simple reason for that. Lack of technology. To accurately and reliably detect such a low voltage, extremely sensitive measurement devices are needed. For a long time, such devices couldn't be developed due to technological limitations. But in this discovery, specially designed, electrical potential measurement devices and plasma detectors were used. The Endurance rocket was launched from the North Pole, because this is where the polar winds are most intense. So, the particles escaping from the atmosphere into space observed most clearly here. The rocket was launched towards a group of islands called Svalbard, just a few hundred kilometers from here. It quickly reached the ionosphere from here. Of course, just developing the measurement device isn't enough for the discovery. It also needs to be adjusted very precisely. So, it's quite a difficult and labor-intensive task. After all these adjustments, the precise measurement was made, and the result was just slightly above half a volt. Scientists have determined that particles are ejected into space at supersonic speeds and are subjected to an external force greater than 10 times gravity. But how is it that an electrical force of nearly half a volt creates an effect greater than 10 times gravity? Even though a potential difference of 0.55 volts may seem small, its effect on the particles in the ionosphere is very significant. Because this effect is felt over a very wide area. This electrical force is acting on all the ions in the area. Since this area covers a wide region, each ion is affected by this force. In a large area like the ionosphere, there are millions and billions of ions. So even a small voltage can have a big impact on all the ions in this wide area. That's why it creates a significant acceleration force, especially on light hydrogen ions. These ions are in a constant flow towards space. You're explaining it well, but you might ask why this discovery is important. Okay, we understand that the energy of 0.55 volts overcame gravity. But why was this discovery reported in big headlines on news portals? To understand this, you first need to grasp the importance of the ionosphere. The Earth's atmosphere is made up of 5 main layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. There's another region between these layers: ionosphere. The troposphere is the layer closest to the surface. All weather events like rain, snow, and wind happen here. Planes usually fly in this layer. Above it is the stratosphere. This layer also contains the ozone layer. As we know, the ozone layer acts as a shield that protects the Earth by absorbing harmful ultraviolet rays. The mesosphere is located above the stratosphere. This is the coldest layer of the atmosphere. The thermosphere, which is located above the mesosphere, is a very hot layer, as its name suggests. The ionosphere is also a part that enables the reflection of radio waves. And our last layer is the exosphere. This is the outermost layer of the atmosphere. It's also considered a transition zone to space. Now, let's move on to the ionosphere. We can say that this is a sublayer of the thermosphere. It covers a region starting from about 60 kilometers and extending up to 1,000 kilometers. Important electrical events are happening in this layer. The ionosphere is very important for communication, navigation, and even space research on Earth. For example, radio waves are emitted from radio transmitters on the Earth's surface and reach the ionosphere. And here, are reflected and transmitted over long distances. Also, the state of the ionosphere can constantly change under the influence of space weather events. For this reason, the ionosphere is closely monitored when planning activities in space. According to scientists, this discovery is as vital for the Earth as gravity and magnetic field. Gravity holds the atmosphere around the planet, pulls the lower layers of the atmosphere towards the surface, and helps create a protective layer around the planet. The Earth's magnetic field helps protect the atmosphere, and consequently, life on the surface by deflecting harmful particles coming from the sun. So, the polar winds work together with these two great forces, namely gravity and the magnetic field, to help shape the atmosphere. The gases in the Earth's atmosphere are constantly escaping into space, influenced by the polar winds. In fact, there's a name for this: atmospheric escape. This situation is causing the atmosphere to thin over time. So, this electric field can have a significant impact on our planet's atmospheric processes and even on the climate in the long run. However, thanks to the Earth's strong magnetic field and thick atmosphere, this process happens as slowly as possible. This electric field, which could only be measured 60 years after its discovery, may play a very important role in the evolution of the Earth and even the solar system. If there is such a field on Earth, why wouldn't there be one on other planets? For example, we know that atmospheric escape has much more dramatic consequences on Mars. NASA's MAVEN spacecraft, launched to Mars in 2013, investigated how Mars's atmosphere is stripped away by solar winds. MAVEN's findings showed that Mars has lost a significant portion of its atmosphere. So just like on Earth, there's also an atmospheric escape process on Mars. With this discovery, we will now be able to understand better how this process occurs on other planets like Mars. Green Cullison from the research team is pointing out exactly this point. And he says that this discovery is a fundamental part of how the world works. And now that we've finally measured it, we can start asking more exciting questions.